So in this video, I'm going to show you how to find the amplitude of this function. And as you can see, it's a sum of a sine and a cosine function in a more general case. And so we're going to find the amplitude of such a function. I've given you a very specific case here with capital A being 3, capital B being 4, and little a being 1, right? And if you look at the color-coded visual and the corresponding graph, the expressions, and the graph, then you should be able to figure out or anticipate what our answer is going to be. Like, you should have some ideas of what's happening, but it's okay if you don't. Let's look at the calculus and the algebra and how to get at the conclusion of the amplitude of this function. So let's first write our function as it should appear, which is equaling y or f of x, something like that, right? So we've got this. I say something like that because it could be g of x, whatever you want to name it. Anyway, got that. And so if we've got a certain function and we want to find its highest point or lowest point, that's a local max or min, we'd find its derivative, right? Okay, cool. So y prime is going to be equal to, I don't know y prime is so far left. We could write it here. It's going to be the following. Right? And when we set y prime equal to 0, then that amounts to the following statement. In other words, this set to equal 0 is the same thing as this statement, right? You should be able to follow that easily. All right, cool. And then next, we could do this. And doing so, we have capital A over B. That doesn't divide out. Only these guys cancel, right? So capital A divided by capital B times cosine AX is going to equal, on the right side, both of these guys are gone, so we have sine AX. But this statement is equivalent to, once we divide by cosine AX, it's equivalent to writing tan AX is equal to capital A over capital B. Not really making, I'm not saying little a and capital A every time, but you get it. Okay, cool. Now, this here is super important to us and the rest of the discussion, so I'm going to write it up here in a slightly different form, and that is by saying that AX is equal to tan inverse of capital A over capital B. Notice that what I just wrote in red, this guy, is the same statement as this guy, yeah? Okay, cool. But I want X, so I could write X is equal to 1 over A, and then tan inverse of, yeah, cool. All right, there we are, and that's X. So, what do we do with this? Well, notice that this is the X value of a local min or a local max. So it's a critical number, but we're not interested in the X value. We're interested in the Y value because that's what's going to tell us, vertically how high it is or how low it is, right? Cool. All right. So what we're going to do is take this X value, which corresponds to the highest or the lowest point, and plug it in for X here and here so that we can find its corresponding Y value. And let's do that in red. Yeah? Cool. All right. So I go Y equals, for this X, Y is going to equal A times sine of little a times X, which we just learned is 1 over A tan inverse of capital A over B, right? And then plus B cosine of A times 1 over A tan inverse capital A over B, which is X. Yeah? Cool. All right. Now, this expression for Y simplifies tremendously. First, we could write the following. A sine this and this take care of each other. So just tan inverse of capital A over B. And then in the second term, we can write the following. through similar simplification or simplifying, we can write this. Yeah, cool. Now remember, tan inverse of a over b is ax right here. We wrote it down, right? And remember, that means that tangent of ax is a over b, because we got this guy from this, right? Anyway, to make more progress now, replacing this with ax isn't helpful, although it is equal to ax. So what we should do is draw a triangle with an acute angle ax. Yeah? Okay, cool. So doing that, let's do that here, will mean that we have this situation. So we've got a right triangle with, it's a little bit like incomplete, but whatever, it's okay. You get it. We've got a right triangle here and an acute angle ax, so that the tangent of ax is a over b, which would mean this is a and this is b. And by the Pythagorean theorem, that would mean that the hypotenuse is root capital A squared plus capital B squared. Yeah? Cool. And now this triangle is going to be very helpful in simplifying this expression for y, because now we see that y equals a, capital A, times sine of tan inverse of a over b. I've already said this. Tan inverse of a over b is ax. So sine of ax is what this reads. But sine of ax, according to this visual, has to be opposite over hypotenuse. So that is capital A divided by, poor division sign, sorry, root capital A squared plus B squared, right? And then plus capital B times cosine of AX. Cosine of AX is adjacent over hypotenuse. So that's capital B divided by root A squared plus B squared. And so this is going to say capital A squared over root. This is an unnecessary intermediate step, but I'll write it in case it is somehow helpful to somebody out there. So, but yeah, you should not need this step. But anyway, I'll do it. It's okay. I'm not making you feel bad if you did need this step. At least you're watching like a math video and trying to learn more math, right? Okay, cool. A squared plus B squared. That comment was completely unnecessary. I caused myself trouble by talking, and then I did more talking to get out of it, which didn't really help. Okay, anyway, this here. So in the numerator, we've got a squared plus b squared to the first power. The denominator is to the half power. Exponent rules say you can simplify it and just write capital A squared plus capital B squared to the 1/2 power, which is saying that the amplitude is root, sorry, didn't like that horizontal line. It's saying, not that either. It's saying that it is root A squared plus B squared. Capital A squared plus capital B squared under the square root is the amplitude whenever you have sine and cosine added in that fashion. Yeah? Cool. Notice that this visual is in complete agreement with our final answer. In other words, you should have had a suspicion that this was going to be our final answer, what I just circled, based on the visual I offered you on the right. Yeah? Cool. I hope you enjoyed this, and take care.